One example of pressure, which is quite literally all around us, is the pressure that the air exerts on our bodies. We live at the bottom of a sea of air. This sea of air is, of course, the atmosphere of the Earth, our home planet. Air has mass, and we feel the weight of air pressing on our bodies at all times. The weight of air pressing in on us creates an immense pressure. This pressure is called atmospheric pressure, and because the air is all around us, atmospheric pressure presses in on us from all directions. But despite the fact that atmospheric pressure is very high in the regions of the Earth inhabited by human beings, we generally do not notice the pressure, because the internal pressure of our bodies balances the external pressure of the atmosphere. As we have said, the atmospheric pressure acting on us is a result of the weight of the air above us, which is pressing in on us. At the Earth's surface, we experience a pressure of approximately 101,000 pascals, or 101,000 newtons per meter squared. This atmospheric pressure pushes in on every square meter of our body's surface with a force of around 10,000 kilograms, or 10 metric tons. That's the equivalent to the weight of 1 kilogram pressing on every square centimeter of the body. It is possible to express pressure in terms of units other than the standard Pascal or newtons per square meter. For example, other expressions for the value of atmospheric pressure include 14.7 pounds per square inch, 1013 millibars, 1013 hectopascal, 29.92 inches of mercury. You may wish to find out more about these ways of talking about pressure for yourselves. Always remember that when dealing with pressure, a gas or a liquid will exert a pressure on an object over the entire surface with which the gas or liquid is in contact. Pressure also always acts perpendicular to, or in other words, normal to, the surface we are considering. We need to establish that whereas force is a vector quantity, pressure is a scalar quantity. Pressure, like speed or temperature, represents a size only and is not represented as acting in any particular direction. Let's now look at ways of calculating pressure and see how mankind uses pressure to his advantage.